Welcome to this short video introduction to chemical engineering at the University of Edinburgh. In this video, we're going to try and summarise what chemical engineering is all about, tell you something about how we teach chemical engineering here, and show you some of the facilities we have. This will replace the usual departmental tour that we'd normally have taken you on during our normal physical open days, and I hope it will give you some feel for who we are and what we do. I'm Dr. Jennifer Skilling. I'm a senior lecturer in chemical engineering. Chemical engineering is one of the 4 disciplines included within the School of Engineering. You may have watched some of the other videos produced by the school, and I would recommend that you watch the video messages from the head of school and the Director of Teaching and Learning, which complement this video. So what is chemical engineering? The shortest definition I can find is that it's the science of converting one thing to another. I would prefer to say that it's the engineering of converting one thing to another. But what from what? Almost anything that is transformed from a raw material to a product involves chemical engineering. All manufactured goods, including electronics, petroleum products, plastics, food, drink, metals, textiles, cosmetics, detergents, you get the message. If you use it, the chances are it had a chemical engineer in its journey to you. But that's the present of chemical engineering. We design processes to make products through physical and chemical transformation of raw materials, and we operate those processes. But chemical engineering has a vital role to play in all of our futures as well. I'm sure that some of you had a thought run through your minds as I listed all the products chemical engineers make, that we're a bit of a problem for the planet. Plastics, fossil fuels, artificial fibres, are we not trying to get rid of these? Well, you're absolutely right. Some of these products, used as we use them now, present a problem for us all. There are issues with how things are made too. The amount of energy used, the waste produced, and the potential risk to the public from accidents, like we recently saw in Lebanon. However, all of these problems are easily reformulated as opportunities and challenges for chemical engineers, and we're involved at every level in finding solutions to these. Chemical engineers are taking leading roles in finding practical solutions to these problems, whether that is in developing new biodegradable polymers, finding new energy efficient ways to make existing products, developing safe ways to use renewable fuels like hydrogen, finding ways to recycle plastics, removing carbon dioxide from the atmosphere, inventing water purification processes to bring clean drinking water to those who do not have it, or developing safety management systems that ensure safer operation of our processes. The solutions to our pressing global problems lie in the chemical engineering sphere, and we will find them. Here at Edinburgh, our staff, students, and alumni are already working in these vital areas. From the fundamental and applied research that our staff do in carbon capture, energy systems, nanotechnology, biomedical engineering, energy efficient separations, and many other areas, to the work our final year students do on placement and that our alumni do once they leave us, the one common theme is that they aim to reduce the environmental impact of what they do, no matter what the industry they are working in. We are proud that as chemical engineers, we are part of the solution. So let's move on now to chemical engineering here at Edinburgh, what we teach and how. Information about the structure of our programmes is available through the Open Day portal, and that will be easier to follow than if I were to describe it in detail in this video. But to give a broad overview, we start in first year with general engineering courses taught in part by chemical engineers. These interdisciplinary, innovative, project-based courses are designed to give an overview of engineering and the interactions between the disciplines. They also give emphasis to building core engineering skills in problem-solving, communication, study skills, group work, and reflective learning. These courses provide a good basis for tackling the more advanced courses and projects which come in later years. The remainder of our students' time in first year is taken up with courses in maths and chemistry. In second year, there's still an interdisciplinary approach where appropriate. So for example, fluid mechanics, which is core to mechanical and chemical engineering, and also civil engineering, is taught to all those students together. At the same time, more specialist courses like separation processes, where we look at distillation, solvent extraction and absorption, are taught only to chemical engineers. In the second year, the core chemical engineering themes begin to emerge. Chemical engineering students continue to study maths and chemistry in that second year. Beyond second year, the programme becomes more specialised, and we deepen the teaching of the core areas of chemical engineering. In third year, these core subjects are consolidated in the laboratory and in design. Both of these bring together the theory that has been taught in a more applied way. Fourth year brings further core teaching and more consolidation, mainly in the design project, where students work in a team to design a process, meeting a design brief provided by one of our wide range of industrial contacts. Students now have the opportunity to take optional courses from a wide range of more specialised honours courses provided by me and my colleagues in chemical engineering and from other parts of the School of Engineering. So these might include advanced process safety, nanotechnology, advanced separation processes, fire engineering and others. These will vary from year to year due to staff changes and timetable constraints. There are only so many hours in a week to teach optional courses. In fifth year, many students take the opportunity to spend 6 months from June to December in industry or in an overseas research lab. Alternatively, they can stay with us and work in one of our research groups on a research project. Students doing an in-house research project also carry out an interdisciplinary design project with students from other parts of the school. The rest of the students' final year is spent on a range of optional courses, broadening and deepening their chemical engineering knowledge. Whatever stage students are at, we have some clear principles in mind in our teaching. We aim to provide not only a strong theoretical background to all of our teaching, but we also have a clear vision of where and how that theory is applied in real-life chemical engineering. Our aim is to produce chemical engineers, not chemical engineering scientists. Our graduates will feel confident that they can leave us and prosper in their graduate jobs. By grounding all of our teaching in fundamental theory, we prepare our students for the fast-changing environments in which they'll make their careers. Chemical engineering has always been a fast-moving discipline, and the global challenges I mentioned before make the speed of change faster than ever. As technologies evolve and transform, engineers who can understand them through the fundamentals will have the ability to adjust to new challenges. However, our students also need to be familiar with today's technologies so that they can contribute in placements and graduate jobs from the moment they start. The feedback that we get from our partners in the 5th year industrial placement programme is that our students are well prepared, adaptable and competent. We have an extensive network of industrial contacts through our own alumni, our research partners and placement employers. We try to bring these contacts into the programme as often as possible. Students in first year interview a practicing engineer. In second year, in normal times, we run visits to local industry. We're fortunate in Edinburgh to be close to a wide range of relevant industry, from pharmaceutical plants, whisky distilleries and oil refineries to a nuclear power plant. These visits give our students an introduction to the sights, sounds and sometimes smells of real chemical plants. Design projects are industrially sponsored, with the industrial sponsors attending the final design presentation. And of course, the placement programme brings our students and our staff into contact with a wide range of sectors, here and abroad. One of the most important aspects of our programme is our laboratory. The Unit Operations Lab, where our second and third year students work, holds a wide range of experimental equipment. Each experiment is directly related to process plant equipment that will be found in a chemical plant, but at a smaller scale. We've chosen to take this approach to our lab rather than having a pilot plant, as some other universities do, for a number of reasons. Firstly, this allows our students to explore a far wider range of applications. It would be difficult to imagine even a full-scale plant that has the range of unit operations that we have in our labs. Secondly, there's the questions of response time. Our smaller scale equipment will respond to changes in conditions in timescales more suitable for lab classes, fractions of an hour, rather than possibly hours for larger scale equipment. This allows the students to see a wide range of behaviour. Thirdly, cost. Both capital costs and running costs of pilot plants are very high. And finally, it's much easier for us to bring new experiments online to reflect new technology. Some of our experiments are adaptations of equipment from our research labs, so they reflect the state of the art. An interesting feature of the third year lab is that some of the most complex experiments have been built by students, in some cases in conjunction with industrial collaborators. The students do this work as summer interns in the School of Engineering. The experience of building and commissioning an experiment, like our distillation column, is an excellent stepping stone to industrial chemical engineering, and the students gain a great deal of satisfaction from seeing their experiment finally work. Other interns on this programme work in our research groups. Sometimes that results in the publication of their work. So who will be delivering this programme to you? Well, we're a group of more than 30 academics from all over the world, bringing to Edinburgh a wealth of experience of teaching and research. Some of us have been here for a long time, so we have in-depth knowledge of how Edinburgh University works and our curriculum, but we're also experienced in supporting students through their journey with us. We also have younger staff who bring energy, new ideas, and more recent experience of what it is to be a student. In combination, we're a strong, versatile, and forward-looking body of staff, committed to delivering a relevant, engaging, and challenging programme in a supportive environment. We want you to thrive, grow, and learn with us. We're pleased to see that our efforts in enhancing and developing our programmes have been reflected in a significant improvement in our league table positions in both the Good University Guide and The Guardian. And this reflects ongoing efforts we're making to improve the student experience. So who are our students? Well, they too come from all over the world. Scotland and the UK are strongly represented, of course, but they are joined by students from a huge range of other countries. Working in such a diverse class is a great introduction to a discipline which is itself very international. This is a great opportunity to make new friends from around the globe. Alongside their teaching, our staff carry out world-leading research in many areas of chemical engineering, pushing back the boundaries of what chemical engineers can achieve. Chemical engineering at Edinburgh is a world-class discipline in a world-class university.